Game Theory Class 2 Video 1. In this video we're going to go through some basic definitions for analysing games. Let's begin. So the first definition has multi-parts. Part 1 is strategies. So in a game, a player's strategies are the player's possible moves. Okay, so a player's strategies are the possible options the player has to choose from. Number 2, an assignment of strategies, one for each player, is called an outcome of a game. So an outcome of a game is an assignment of strategies, one for each player. So you imagine it as each player has chosen a strategy, and then that is an outcome. And number 3, the payoff for a given outcome is the result of that outcome occurring. The payoff of a given outcome is the actual result of the outcome. Okay, so for example, if we re-examine the prisoner's dilemma, this is a game I described in the previous video. Well, we know that the strategies for player 1 and I'm just going to use shorthand. P1 is going to be shorthand for player 1, for person 1, are to be loyal and betray. These are the strategies available to player 1. And similarly, in the prisoner's dilemma, player 2 has the same strategies available. It's not always true that in every game all the players have the same strategies available. Sometimes in some games, certain players have different choices than other players. But in the prisoner's dilemma, both players, player 1 and player 2, have the same set of choices. They can be loyal or they can betray. These are the strategies available to them. A possible outcome is, I could write it as loyal, betray. And what this means is player 1 is loyal and player 2 betrays. That's what this means. Okay, so the first thing refers to player 1 and the second thing refers to player 2. So this is an outcome. This is one possibility for what could happen. And the payoff for the outcome loyal betray is, well, the payoff is what actually happens. So what actually happens is player 1 gets 3 years in jail and player 2 gets set free. or 0 years in jail. This is the actual payoff for the outcome, loyal betrayal. Okay, so this is just an example using the definitions I gave here. Let's move on to a different definition now. So a new definition. And this definition, it's about condensing the information into a nice, dense form so that we don't have to keep writing all of these long words all the time. So what I'm talking about is a payoff matrix. A payoff matrix. So the payoff matrix of a two-player game, I didn't mention, but most of the games we will consider will be two-player. It's just the easiest, it's an easy assumption to make. Okay, you can have games with multiple players. Like in the previous video, we looked at a game which had 10 players, but in this course, we're mainly going to consider two-player games. So the payoff matrix for a two-player game is the table whose rows are labelled by the strategies for player 1 and whose columns are labelled by the strategies for player 2. Okay, and whose entries are the corresponding payoffs. So that's a long definition, okay? And it's maybe a bit confusing, but once you see an example, I think you'll realize it's pretty straightforward. So the payoff matrix for a two-player game, it's a table whose rows are labeled by the strategies for player 1, and the columns are labeled by the strategies for player 2, and the actual entries in the table tell you the payoff for that corresponding outcome. Okay? And before I go any further, just a note. When I say the entries are labelled by the payoffs, we tend to just use numbers to talk about the payoffs. So we assign a number to the payoffs. If you're familiar with economics, it's this notion of utility. Okay, so we assign a utility for the different payoffs. And in general, positive numbers are good. Positive numbers equal good. And like the larger the positive number, the better. So 7 is better than 3. Okay? This is just how utility works. You assign a number which tells you how desirable it is. I'm mentioning this because the first example I want to do is the prisoner's dilemma. So back to the prisoner's dilemma. I told you this is going to come up a lot, and it really is going to come up a lot. Okay? So the prisoner's dilemma. Where are we? What are we doing? So we want to know the payoff matrix for the prisoner's dilemma. So before I do that, I want to come up with a shorthand for the strategies. So I'm going to say that loyal, I'm just going to denote by an L. It's not a very good L, just an L. And betray, I'm going to denote by a B, like that. And the payoff matrix is going to look like this. it's a table where I'm going to write LB, LB. Up the top, this is player 2. On the left, it's player 1. And then the entries of the table are the payoffs for the corresponding outcomes. So if we look at this entry here, loyal, loyal, in this case, both the players get 1 year in jail. Well, 1 year in jail is usually not seen as a desirable thing. So I'm going to write -1, -1. Okay? I don't write 1 because 1 is a positive number and that would be seen as a desirable thing, but it's not desirable. Okay? I'm just going to try and space my table out a tiny bit. Okay? So if we look at this entry right here, loyal, betray. In this case, player 1 is loyal, but player 2 betrays. So that means player 1 spends 3 years in jail, and player 2 spends no years in jail. If we look at this one down here, player 1 betrays, player 2 is loyal. So it's sort of like a symmetric situation, 0 minus 3. And finally, if we look at this entry right here, both people betray. That means they both spend 2 years in jail. So it's -2, -2. This is the payoff matrix. For the prisoner's dilemma. Okay? And notice how it contains all of the information just in a really condensed form. And this is how we will be using and thinking about games for the majority of this course, because it's just too much of an effort to having to keep write out the story, the backstory. So instead, we encode it into this payoff matrix. Right? All the information is here in a really dense, convenient way. Oh, I also just wanted to mention, like, matrix. The word matrix is just a fancy word for table. Okay? Like, as far as we're concerned, matrix is just a fancy word for a table. So a payoff matrix is just the payoff table. And this is the payoff matrix for the prisoner's dilemma. So let's do one more example. Okay. In game theory, there's lots and lots of famous games, and we're going to talk about them as the course goes on. Another famous game I want to tell you about now is called Matching Coins. And to be honest, this is a pretty boring game, but it's famous, so I should tell you about it. So it's a 2-player game, okay? Both people, they secretly choose either heads or tails. So they choose heads, which is just capital H, or tails, which is capital T. And the outcomes are as follows. If they both choose the same, then player 1 gets +1 and player 2 gets -1. And if they choose different, then player 1 gets -1 and player 2 gets +1. So this is the game, okay? And now I'm going to draw the payoff matrix for this game. So it's a 2x2 game. The possible strategies for player 1 are heads and tails. The strategies for player 2 are also heads and tails. If we look at this entry here, heads, heads, that means they both choose the same. Heads, heads. So that means player 2 gets +1, and player 1 gets +1, and player 2 gets -1. If we choose this entry here, heads, tails, in this case they chose differently. So player 1 gets -1, and player 2 gets +1. This one here, they chose differently, so player 1 loses a point, player 2 gets a point. Finally, tails, tails, they both chose equally, so player 1 gets a point, and player 2 loses a point. This is the payoff matrix for this game here. Okay, and that's it for this example, and it's it for this video.